Hey coders, welcome back. In this is our day 11, I think, of our video series where we are solving this mock assessment from LeetCode. So if you don't know, there is a page on LeetCode. So it's like leetcode.com/assessment. You can go there, and then you have like these three options, the free ones, right? We have also Google, Meta, Amazon, but they are paid. You need premium account for those. Yeah, but these three are free and you can choose any of it, right? So either OA1 or the phone interview one or the on-site interview one, and you're gonna get like three or four questions, two questions, right? Random from a company, and those questions are like the questions which are being asked in real company, right? And then you try to solve it under a limited time, right? So yeah, this is what we are doing. So this is our day 11. And last time I did this on-site interview one where we solved three questions. So one was I think on linked list, reversal, and palindrome finding. Then flatten and doubly linked list was there. One more question, and one more question was there on sorting, basically on custom comparator. So yeah, let's see. Let's go today on phone interview one and see what questions are gonna come. And yeah, so my all this video as usual, nothing is edited here. Whatever I thought, whatever I type, it will be presented on the YouTube. And even I don't know what questions are gonna come. So let's see how it goes. So yeah, I say here up to three questions, right? And means one question, two questions, are three questions, and then we have like 90 minutes, and you cannot pause the timer and all. So let's start the mock assessment. See what questions are there. Okay, so we have three questions in this session. Let's try to solve it. Yeah. So in this question, it says like given a string S, find the first non-repeating characters in it and return its index. If it does not exist, return -1. So here you see L is the non-repeating characters because L is at index 0 is the first character that does not occur at any index at all. Okay, you see, so here L is coming only one time, right? And there is no other characters. And for these ones also, you see here 0, 1, 2, V. We say vowel. It has not been repeated, and this is the very first character. So we are returning the index 2. Here everything is repeated, right? AA is coming two times, BB is coming two times, and that's why we are returning -1. And if you see the constraint, it's like 10 to the power 5, right? So you have to solve it a linear way. Basically, your algorithm should be linear, right? Otherwise, you will get the TLE. Okay. So what's the idea? Um, idea is pretty simple. If you have solve to some kind of problem, right? So basically, what needs to be checked? Let me show you. Let me copy this here in the editor and just to zoom a bit. So you see here lead code, right? So let me do some spacing around it. Okay. So what's the idea? Idea is whenever you go on any character, you should have the information somewhere to check whether this has been seen earlier or this has been occur in the remaining of the string or not. And that's the idea. That's the question is saying. Now, in the easiest way, what you can do, you take this L and try to find in the right side, do we have L or not? Right. And you see, we do not see any L here, and that's why this is the answer. But since the constraint is 10 to the power 5, we cannot just check everything. We have to somehow make sure we store the information, right? We store the information and then we're gonna return it. So let me zoom out. So how we gonna do that? So what I'm thinking is, let's say we are going on this T, right? And then we have to check whether we have seen this T before or not. Hmm. Maybe what we're gonna do now, we can just um just store all these characters frequency maybe. So you see here it is a, like a lowercase English letters. That's good. We're gonna just store the frequency of each character, right? And I think that's it. And then we're gonna iterate over the string one more time and check which character has a basically frequency is one, right? And that will be linear. So this is what I'm currently able to think. Maybe as soon as I start typing, maybe I start getting some other view. But this is what. So initially now, what I'm gonna do now, I have this frequency array, right? Where I will store the frequency of each characters A, B, C, D, E, F, G, H, everything, right? And then I'm gonna again iterate over each of this character and check whether the frequency of them is one or not. So if someone's frequency is one, so that will be our answer, right? Because it simply means it has not been repeated, right? Let's write that. So either you can use map or you can use the frequency array because here if you see now the S is the only lowercase character, right? So you just need to get a frequency of of 26 size, right? And that will work. Or if you're comfortable with a map, you can use map also, right? That will be also constant actually because big O of 26 is like constant, right? So let's create a frequency array, right? Um, Frequency array of 26. So frequency of 0 means we are storing count of A, right? 1 means B, 2 means C, and dot 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 dot, right? And let me store the size of this string, and let's iterate over all the characters of this string and just append the frequency, right? Something like that. This is the first step. Now, in the frequency array, we have frequency of all these characters. Now, what's the next step? Next step is again iterate over each of this character. Now, since we need index of it in the answer, so we have to maybe do something like this. Iterate as an index from n plus plus and maybe char ch. Uh, that will be s dot char at char at I, and then you have to check the frequency of this character, right? So how we're gonna do that? So we can say something like if frequency. Now you see this is ch is actually sorry. So let's say if it is a b, then we have to check it at the one index, right? So we can simply say whatever the character is there, we have to add 97, something like this, or maybe I can uh, do in separate line like this. Int. Do I need to do force typecasting? I don't think so. I can simply say ch plus 97. Um, no, not 97, minus 97, right? Because if it is A is will be 97, right? And 97 minus 97, 0. So that will be position. So if it is a B, so B, a sky code will be 98. So 98 minus 97 is equals to 1, right? So this is the position we need to check. And then if frequency of position, oops, position equals to 1, then we can simply return this index. Otherwise, we are not able to find anything, right? So yeah, this part maybe if you're not comfortable, so let me show you why I did this. So now, so capital A has a sky weight of 65, right? And a small a has a sky code of 97. So if I need to check whether A is what is the frequency of A, so I am just doing 97 minus 97, right? And that will give me the position of A. If you're not comfortable with array, you can use the map and think that will be much simpler. But yeah, this is also one way you can do that. So let me try compiling it and see do we have any compile time error. Yeah, we are getting 0. Let's see for this one also to make sure before submitting. Sorry, guys. Okay, we are getting to. Let's try submitting it. See, we are able to solve it. Um, so yeah, I think this is the best we can do. And you see here, the frequency we are using array is 26 size, right? So it's like a constant. It's not a huge space. So it is a linear solution, right? We are only iterating each of these s characters once here and once here. So yeah, nothing fancy. You should be aware if you're sorry if you are solving using frequency array, you should be aware with different ASCII value, right? To understand this logic. But I think this is easier. Um, yeah, so let's move to the next question. Okay, linked list. I think yeah, from yesterday we are getting a lot of linked list questions. And to be honest, I don't like linked list. So given a head of a single linked list, okay, we have to reverse the list and return the reversed list. Okay, okay. One, two, three, four, five. Okay, just a typical reversal. So, okay, so on solutions, you can find a reversal of linked list using two pointer and three pointer. I generally prefer three pointer because it's very easy to understand, and that's why I like it. So let me show you how I think about it. Let me show you maybe one example, two, and then we have a three, then we have a four, right? So let's say this is our linked list. Okay, right? So what I'm gonna do now, I'm gonna create a previous pointer just before one, right? And it is basically pointing to null right now. Um, yeah, something like this. I will create previous, and then I'm gonna create one more pointer at current that will point to this one, and then one more pointer next that is pointing to two. Right. So this is the very first step. I'm creating previous, then I'm creating current, which is the head, and then the next pointer, which is the current dot next. Right. Now what needs to be do? We just need to do current dot next. Basically, change this pointer to other opposite. Make it basically make it opposite. Right. One pointing to two is making one pointing to this null. So what's the step one? Step one is current dot next is equals to previous, right? So this pointer will get changed. And now you see why I'm keeping this next, because this pointer is getting changed. We need to somehow access this element also, all these elements. So that's why I'm keeping track of here in the next pointer. So after doing this first step, now this 1 to 2 becomes 1 to null, right? And then next thing is pretty easy. I just need to say previous is equals to current now. So this is my two second step. Basically, I'm moving all these pointers to something like this. You see, from here we change the pointer. Now I have to move all these my pointers to here. Basically, go to the next set of changes. So I hope you understand this. Let's quickly write code for this. Um, so as we discussed, we need previous, which gonna be null, and current, which is gonna be head, and next, which is gonna be head dot next. How many elements can be there? There might be a zero element. Number of nodes may be zero. So for zero, this will be head dot next will give me null counter exception. So let's handle that. If head equals to null, simply return the head. Right. So this is what we created. We created all these pointers, right? Something like this. Something like this. Now, while current is not equals to null, we have to do our all this shifting. So as we discussed, current dot next is equals to previous, right? Step one. Step two, previous is equals to current. Step three, we need to move our current also, right? Now current it becomes next. Step four, if next is not equals to null, then next is equals to next. This is it. And then we're gonna return the previous. Why? Because you see here, after all these have done, so we move to like this, then we move to this, then we move to this, and then we move to this, something like this. Now you see the previous will contain my new head. You see? Let me show you again. So we were initially like this, right? After all this traversal, we go here, then traverse here, and then change all these pointers here, change all these pointers, and here change all these pointers. And now here the current becomes null, and previous containing the head. So that's why I'm returning the previous. Pretty easy, right? Let me compile it. DNA error, compile time error. Yeah, 54321. Let's try submitting it. Okay, yeah, pretty easy, I think. Um, yeah, just remember these three pointers and how we are moving, right? And the rest of the things will be easy. Sorry. Let's move to the third question. Okay. So it says there is an integer array num sorted in ascending order with distinct value. Okay. So array we are given. No. There is an integer array nums sorted in ascending order with distinct value. Prior to being passed to a function, nums is possibly left rotated an unknown index. Okay. Such that the resulting array, these things, for example, this array 0, 1, 2, 3, 4, 5, 6, 7 might be left rotated by 3 indices and become like this. Okay. Given the array of nums, after its the possible rotation, an integer target, return the index of the target if it is in the nums, or return -1 if it is not in the nums. You must write your algorithm in logarithmic time. Okay. Excuse me. So the question is saying something like this. So let's say you have a one array. Um, let me do something like this. 1, 2, 3, 4, 5. I think 4 will be enough. Yeah. Initially, now we have this array, and they what they did was they randomly left rotated it, right? So left rotation means how they are doing. You see here from 0, 1, 2, 3. This 0 is gonna be here. Okay, okay, yeah. So this one is going to be put it here. This is like if we say k is equals to 1, so we rotate one time the whole array. And if I rotate the one time whole array, my array become 2, 3, 4, and 1, right? If my k is equals to 2, okay, why this is not perfect? K is equals to 2. Now again, I will rotate it. So 2 will goes to here again, right? So it will be something like this. 3, 4, 1, 2. Right. I hope you get the idea. Now it says doing this rotation, we have to find a target, whether a number exists in our array or not. Right. Um. Yeah. So you see, if and the questions is asked explicitly, like we have to solve in logarithmic type. Otherwise, you can do the simple linear search, right? So for example, for this one, you can just check is it 0, 0, 0, 0. Yeah, here we find a 0, return the index. But that will be linear and too simple. That's why they have asked to solve it in logarithmic time. Now, one thing is very clear. Whenever you see you need to find a target from an array in a logarithmic time, there is a no algorithm other than binary search. I can guarantee you that in a sorted, in a, any kind of array. If they are saying you have to find a number, whether that exists or not, so that will be logarithmic. Of course, you can use set or map, but that will also be linear, right? There is a no other way. This is the only way you can find a number exists in an array in logarithmic time, binary search. Full stop. Nothing else. Right. So for these kinds of question, where something got rotated, you have to observe one thing. And let me show you what is that. So something we call, I don't know. There is a terminology for this one, and I'm not able to remember. So you see how this array is there: 4, 5, 6, 7. So it is keep going in up, 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 and after a some place, it goes down, right? So you see 0, 1, 2 now. So it's not like what we say. Um, if there is a one thing we have studied and some method. I think increasing method, strictly increasing and decreasing kind of method. So You see here it is keep going up, 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 and then it goes down, and then again up. So if you see for all these rotations now, so let me show you for this example, 1, 2, 3, 4, and then it become like this, and then for the next rotation it will become like this. Comment it out like this, and for the next rotation, let me align it right, and for the now next rotation it will becomes like 4, 1, 2, and 3, and the next rotation it will become again 1, 2, 3, 4. So you will observe one thing, and what is that? It is going up, up, up. So for this one we are good, right? So if the very first element it is smaller than the last element, this means the array is already sorted. I I can assure you that based on this example, right? So we have all this possibility of the rotation, and I can arrive on this thesis, right? Because if the first element is smaller than the last element, the array is already sorted. If it is a not, so we're gonna have something like this: 2, 3, 4, 1, 3, 4, 1, 2, 4, 3, 4, 1, 2, 3, and yeah, this is these three, right? So so what is the step going to be? So we have to found this point, the peak point where the things are getting bad, things are getting dropping. Like you see, from 4, 5, 6, 7, it was good, right? And if we are able to find something index of 0 in this example, so let's call it like a pivot. So we can guarantee that after the pivot, the array is sorted. Before the pivot, array is sorted, right? And then we can do the two binary search, one on the left side, one on the right side, and get our answer, right? So let's say for this example, let's say for this 3, 4, 1, 2, what is gonna be my pivot? My pivot is gonna be the smallest element in this array. How cool is that? Because if you are able to find out this pivot, like one here, and you know that all the elements in the left side will be sorted, all the elements in the right side will be sorted. Similarly for here also, for 2, 3, 4, 1, you can guarantee that before this element everything is sorted, and after this element everything is sorted. So we have to first somehow find this pivot, and how we gonna find that? It is using binary search. So the first thing is, let me write, um, find the pivot, and then second is uh, ta- try to find target in left side of the pivot. If found, very good. If not, try to find target in right side of pivot, right? Pivot. You can call it anything, but I call it pivot because if you have solved a quick sort algorithm, we generally call it like pivot. So everything before the pivot, everything after the pivot, right? Something like that. So yeah, this is the idea. The first thing is we have to find the pivot, and that is also we need to find out using binary search, right? Otherwise, the algorithm will become linear. We cannot just search and find the most minimum number in this array. So the very first thing is I'm gonna get this size of the array, and I will call it T maybe. And the first thing is find pivot. Now, before that, if I can say if um mm, 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 no, I think this is fine. That will be extra edge cases handling, and it will make, let's say, a find pivot method, and I will say nums. That's it. So this, let's try to write this find pivot method. I can say private and maybe public. No, can do anything because we need to call this inside the same class, so it doesn't matter. So public int pivot int a. We have to find the pivot. We do typical binary search. Left is equals to 0, right is equals to a dot length minus 1. and then while left is less than right, we're gonna get our mid. Right. And if now here's the thing that you have to focus. One more thing. Okay, let me go up a little bit. So if you see, you just have to see this and try to understand it, right? And there's nothing like a magic, because if you haven't solved this kind of question before, it's hard to come out. I can assure it. So if you're not able to solve these kinds of questions for the first time, it's totally fine. Even I'm not able to solve it, if I remember. So what's the idea? Idea is we just need to. So let's say for this we wanted to find the pivot for 3, 4, 1, 2, and I know my pivot is here. It is the smallest element, right? So let's say my middle is pointing to this number 4, and we just need to compare 4 with the very last element. So this is crucial. So we're gonna compare 4 with the very last element and check, is it smaller, is it greater, right? And since here 4 is greater than 2, right? So this means our inclining is happening just in the right side. We have this a mountain, so we have. If I can draw it somewhere, no, I'm able to show you. But you see, just focus on my cursor. So we are going something like this. We are going from here to up, 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 right? And then we find some index, and then where we are dropping, right? So we're going drop, and then again we are going up, right? So this is what we are trying to say. So if I'm saying just compare my middle element with the very last element and see. So 4, if it is, so if you can see, if 4 is greater than 2 and this is right, so we have to find our pivot in the right side. And this is going to happen for everything. So let's say for this one, right? Let's say our middle element comes here, 2. Now 2 is smaller than 3, right? So we have to find here in the left side. Here you see, if 4 is my middle, so I'm gonna compare with the very last element, and it is 4 is greater than 2, so I have to find in the right side. So I hope this is clear. So let me write the same thing here. So if A of mid is greater than A of um let get the last element um n minus 1, then what we have to do is what we have to do, right? So here, for this case, 4 is greater than our mid is greater than the last element. Then this means we have to go on the right side. So if we can write something like this, suppose that, and otherwise left is equals to mid plus 1. I always try to do right is equals to mid and then left is equals to mid plus 1. I don't know. It just like it makes me, because I always do some. So I just change the condition. If I always try to make my right is equals to mid and the very first thing, then left is equals to mid plus 1. Of course, you can change the signals and this comparison and you do vice and versa thing, but this is what I follow, right? So let me show you again why we have done this. So for example, let's say our mid is here 2, right? Now 2 is less than 3, right? So we have to find our pivot in the right side. So we are reducing our search space in the left, right? And then and we know that always our left gonna be exist, so I can simply return the left, right? So now we have our pivot index. Now what we need to do? We need to do um search the array target element in the left side of a pivot and the right side of the pivot, right? So I can simply say if nums of pivot equals to target, return the pivot, right? And this is the case. And then either try to find in the left side or the right side, right? So let's say left check maybe, and I will say search maybe my method name, and then I'm gonna pass nums. Start index will be 0, and this will be pivot minus 1. Right. Similarly, right side, right check maybe. Search nums pivot plus 1, uh, 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 pivot plus 1, and n minus 1. After this checking, if uh, nums of LC equals to target, return LC, right? And if here nums of RC equals to target, return RC, otherwise return minus 1. I hope this is clear. And I just need to make sure now this pivot minus 1 is greater than equals to 0, then do this, right? Otherwise, it doesn't make sense. Otherwise, I will go minus 1 and it is not good. So if pivot minus 1 is greater than equals to 0, then do this, right? And here also I can do some checks. If pivot plus 1 less than n, then do this, right? And let's now write our search method. So search method is gonna be very simple, typical binary search. What's the name? Search, right? Um, int nums, nums left, right? Then I'm gonna simply create my made, which is left plus right minus left of my 2, right? And if nums of made is greater than equals to target, right is equals to mid, else left is equals to mid plus 1, right? And okay, we have to do this in while loop, no? While left is less than right, do something like this, right? And then here I can say if nums of left equals to target, which I need to pass, return left, else return left minus 1. Else maybe return 0, just dummy value. And that we are, since we are checking here also, I can return minus 1 maybe, and then I can check here if it is a minus 1 continue, but I think this is not bad, right? And in the search, let's also pass this target also, so we can check. um yeah. Oops. We are passing as int, and I need to do this target, right? And I think I just need to return the left here, nothing else. So we are passing this target and we are checking the binary search. So I'm using again my predicate based binary search. I really like it. And you can do your typical binary search also, right? No worry about that. And here we are checking at the pivot. Then we are checking LC. That's fine. We are checking here also. This is fine too. Pivot plus 1 to n minus 1. That's right. That's right. And yeah, I think this is it. Let me try compiling it. See any compile time error. We have find pivot. You cannot find the symbol. What we have to do? Find pivot, not pivot. Any else error? Two errors is there. Line number 16, we have one error. Let's see what I missed. Okay, I missed this one. We are using target now TH, right? So let me again try it. Okay, so we are getting 4 for this one, and that's fine. Let's see for this one. Um, okay, I will remove this thing, and I will try to find 3. Let me run it. Okay, -1. So let's try submitting it. See, uh, we have any runtime error? Maybe. I don't know. No. So yeah, we are able to solve. I think it's been like 35 minutes for all these three questions. So yeah, this one is good question. You have to have an idea for this one. If you haven't solved this kind of question before, it will be hard to come up with, right? I can assure you. So I believe I can solve. I have solved this question like 3 4 times, not like recently, but like 6 or 7 months ago. I solved it. So yeah, I know about it. And for this one, I think nothing fancy. I mean, just need to track the frequency. hmm This is very trivial. You should know how you need to reverse the linked list, and just remember my this three advice, right? And you will be good. You are never gonna be forget about it. And this is question number three. Yeah, custom binary search. So I think in C++ and Python we have lower bound, upper bound thing. We don't have here in Java, but this is typical. You can solve it, right? Yeah. So I hope you like it, and thank you so much for watching.